In this video, we will look at causal forecasting models. We're going to look at the simple or single, and then we'll look at a multiple regression. We'll solve the simple one with Excel's functions and their data analysis regression pack. And then the multiple will solve with just the data analysis regression pack. So if you don't have your workbook set up like this, you'll want to pause the video here and set the workbook up if you want to work along. First of all, we'll take a look at our data. We have selling prices for 12 homes and the size in square feet times 1,000 for the 12 homes. And what we want to do is use our independent variable X size to forecast our dependent variable Y, the selling price. We're going to use the intercept and slope functions in Excel to make that forecast. So we'll start with the intercept function. The intercept function tells us where our forecast crosses the y-axis. So where it begins. It wants the known y's. That's why I've labeled them here, y, so I can tell which column to put in. Then it wants the known x's. Here are the x's. I put those in. That tells us that at minus 8.13, the forecast crosses the y-axis. Now we need to know for every unit of x that we move across the x-axis, what is the change in y? What is the slope, the rise over the run? So we'll use the slope function in Excel. Again, it wants the known y's and the known x's. There's the slope. Now, if we wanted to forecast, for example, the selling price for a house with 3,100 square feet, we would take the intercept and add it to our x value times the slope. And that gives us $295.02 or $295,000. The standard error of the estimate is the Excel function steyx. Again, it wants the known y's and the known x's. The correlation coefficient, or Pearson R, uses the Excel function correl, and it doesn't care which order you give the values in. I give them in the same order just out of habit, the y's and the x's. Make sure to get the values, not the titles in this case. And then the coefficient of determination, or R squared, equals R squared. That tells us that if there's a change in y that's caused by x, our model explains 49% of that change. That's not a very good number. We like to see 70% or above. Now the Pearson R indicates a positive correlation that's moderate. 70% is right at the border between strong or high and moderate. All right, now let's use the regression tool pack in Excel. We'll go to the Data tab, Data Analysis. We'll locate regression in our data analysis tools. You'll have to scroll down to regression, say OK. We're going to select our Y values, and I'm going to select the labels as well. I get one row for the labels. My X values, I have them labeled here, X. I'm going to select the labels. Then I'm going to indicate here that I've selected the labels. I have a confidence level for this problem of 95% for an alpha of 5. That's important to remember. If I wanted to change that, I could check here and change that to 90 or 99 or whatever I wanted. Of course, my alpha would be 1 minus whatever this value is, 1 minus the confidence level. I'm going to change my output range, and notice when I select that, this cursor moves back to here. That can be a problem. I need to make sure I put my cursor down in the output range because I want to put my solution right here. So I'm going to click on F2 in my case and select OK. Now it's going to generate this table, which as you can see is going to provide me with the data that I calculated here earlier. So I have the Pearson R, which is in our table referred to as the multiple R. You'll notice they're the same values. I have the R squared. I used R squared in this case because I have only one X. If I had multiple X's, I would have to correct for the relationship between the multiple X's. So I would use the adjusted R squared. But I have one X here, so I'm going to use R. You can see it's 0.49. That's where we are here. My standard error, those match. You can see my intercept matches the intercept. I will ignore these values, these intercept values. They don't mean anything to us. You can see that my coefficient for my X variable, which because I selected labels is nicely labeled here, which is helpful, matches the slope value. And you can also see the P statistic here. The P statistic helps us determine whether we want to reject or fail to reject the null hypothesis of the Pearson R test. The null hypothesis of the Pearson R is that R equals 0. In other words, there is no correlation. Correlations can range from a -1 to a perfect negative correlation to a +1 for a perfect positive correlation. But 0 indicates no correlation. So R equals 0 here. A p-value of 0.01 is less than our alpha value of 0.05. Remember, we selected a confidence interval of 0.95, so our alpha is 1 minus our confidence interval. That gives us a 0.05. Because the p-value is less than 0.05, that means it's outside our confidence interval, so it's in the range of rejection. So we're going to reject the null hypothesis that there is no correlation, that R equals 0. So we're going to accept that size is significant as a predictor of price in this model. 70% correlation, it's not that great, but according to our p-value, it is significant. All right, now let's take a look at a multiple regression model. We'll add to our data land area. So now we have the number of acres that the house is on, the square footage of the house, and selling price. Notice that we're careful to put our X values next to each other. Sometimes the problem is given to you with Y interspersed. It doesn't matter if X is at the beginning or if they are at the end. They just have to be contiguous. They have to be next to each other because of the way our analysis tool pack wants us to give it the X values. Now in this multiple regression model example, we need to use the analysis tool pack to do our calculations. So we'll go straight to that. I'll go ahead and place my cursor here, go to data analysis, regression as before. You can see it's kept the values from the previous, so I want to be careful to take those out. Now in this case it works all right, but I'm going to take them out and put in the new values just to make sure that I'm right. Here are my Y values that it's asking for. I include the label. I get one row for labels. I'll take out my X range, be very careful to get the labels for both columns of X values. ensure that the labels checkbox is checked to show that this first row is labels. Now, if you leave this off, it'll use these numbers as labels and your data won't be correct. So pay attention to this. Confidence level, again, is at 95%, so my alpha is 0.05. My output range, I'll make sure that is correct. I'll select that value and go up here and select where I want the output to go and say OK. Now I get my values again, and you can see that I have a much stronger correlation, 93, 94%. I use the adjusted R-square in this case because I have two x's, and if there is a change in y resulting from changes in x, our model predicts 84, 85% of that change. We have the intercept here of 99.92. We have the slope for our size variable at 21.38 and the slope for our land area at 115.03. I'm going to go ahead and use these values to create a forecast for a situation where we have 3,100 square feet and 0.9 acres. So to create that forecast, what we're going to do, I'm going to set this so that you can see it a little better. Shove that over to the right. I'm going to take my intercept from my table and I'm going to add that to. I've got the slope for the size, and I'll multiply that times the factor for size, and I'll add then to that the slope for land area times the land area for which we're forecasting. Close those and press enter. And there we have the forecasted selling price given a house size of 3,100 square feet on 9/10 of an acre. Now we go over here to the p-values and we take a look at them. Remember, the null hypothesis of the correlation coefficient, or the Pearson R, is that R equals 0, our alpha value. So we're going to take a look at these two values. First of all, we see 0.352. That is greater than our alpha of 0.05, so we failed to reject the null hypothesis, which means the correlation equals 0. So given the presence of land area, size is no longer a significant predictor of selling price. The land area does a much better job, as you can see, at 0.00051. We see that that is significantly less than our alpha value of 0.05, so we will reject the null hypothesis of the Pearson R test. For correlation, that R equals 0, there's no correlation. So because we reject that, we say that there is a correlation. Now, if we were to run this model again using just land area, you'd see that we'd still have a pretty significant predictor even without including size into the equation. So that would mean we don't have to process that variable. Of course, we'd have to collect it as a realtor, but it can result in a savings because it's just less data that we have to process. And that's how you perform the simple and multiple regression analysis using Excel's analysis tool pack for the multiple, and for the simple using both the tool pack and the functions in Excel.